Fantaye, who's from Ethiopia, and he's a data science specialist, works in cosmology on big satellite projects and learning from the universe. He's also a Arete chair at AIMS South Africa. And then we have Professor Amanda Weltman, who, so if you could go up, she is at University of Cape Town, and she holds a chair in South Africa in physical cosmology. So she's another cosmologist, this time more on the sort of basic theory side of cosmology. Then fourthly, we have Dr. Prince Osei. So Prince is from Ghana. He is expert in quantum gravity and topological field theory, so again, very mathematical physicist. But he has two sides to his character. He's also the project developer of Quantum Leap Africa, which is intended as a real moonshot research center here in Rwanda. And so recently Prince became a radio astronomer as well. Seriously, he is installing an amazing little radio telescope which will operate here in partnership with the Hyrax telescope in South Africa. And by 2019, we're expecting some really exciting discoveries to be made here in Rwanda. The final one is Dr. Prosper Ngabonziza. And so he is a true local. I met Prosper in 2010 when he came to AIMS South Africa as a young, and if you don't mind my saying, timid Rwandese who spoke only French and had to do all his studies in English. And quite honestly, I could say we were not sure if this guy is going to succeed. He had everything against him. Anyway, Prosper is now a scientist at the Max Planck Institute, staff scientist, Max Planck Institute in Germany, after a PhD in quantum materials. And not only that, he's on the steering committee of a very, very exciting project, which is the light source proposal to create a $250 million facility here in Africa, which will be state-of-the-art material science. So Prosper has kind of gone from obscurity to high prominence in record time. And I'm going to ask Prosper of all of them to give a little presentation, so he's got some slides. But for the rest of them, we're just going to be in discussion mode. We want the session to be totally interactive, totally informal. How should I say? Feel free to be controversial. Even Bruce. Okay? Be controversial, be honest, raise any problem. What's wrong with physics? Okay? What's right with physics? We want this sense of openness and, welcome. Please, come, can you come and sit in the front row? So this is the director of the East African Institute for Fundamental Research, which is actually going to focus on physics and master. He's a condensed matter physicist. So just emphasizing, we're going to have a free-floating discussion, controversial, challenging. What are the, don't feel free to raise anything, and we'll do our best to discuss it. So without further ado, let me introduce each of the panelists. I guess we'll just have a personal statement. They can choose to address whatever they like. So let's start off with that, 2 minutes or 3 minutes from each of them. And then I would like to go straight into discussion, questions and answers, and so on. Proceed.
Hello. So I'm Jonathan Esole. I'm from the Democratic Republic of the Congo. I have a tendency to forget the democratic part. So I am a mathematician. I got most of my degrees in math. I have a degree in physics. So maybe what I'll talk about is my road from the Congo to where I am now. So I was born in Kinshasa a very, very long time ago. And when I was 3 years old, I moved to Brussels with my family. My dad was pursuing his PhD in Brussels and Paris in philosophy and anthropology. And I grew up with some physical difficulties. I had a near-death experience when I was a child. So being in Brussels was great for me because I get to be able to fix, for example, using my hands and learning how to speak properly. So I was like a special needs child. Yeah. So growing up, my experience was more like sitting at the back of the room, seeing the other kids play. I couldn't ride a bicycle, do nothing. And my brother was like my hero. He could run fast. And in my mind, I was thinking everything my brother does, it's like me doing it. That's what I always had a big ego, you know. So I was just like surviving through imagination.
Wow.
Then they gave me that book. My first contact with Einstein when I was a child was like someone told me that fake story that Einstein used to fail at school since I was not doing really well.
Yes, I'm like him.
I was like, oh, there is one in my team who ended up doing so well. So I got interested in math, but I was really, like, until now I still have like some problems. Once in a while I can't really use my hand. And when I was at university, my second year at university, I spent 1 year, I had to pass all my exam in oral because I just lost use of my hand. But
in Belgium?
In Belgium, yeah. But then, as I was growing up, like, you know, I was speaking French, so writing and speaking French is difficult, so I was not good at it. But eventually, when the math became a bit more abstract, I felt extremely comfortable with it. And by the time I was, I think, the equivalent of 7th grade, I was always reading secretly my elder brother book. So I finished my math curriculum when I was like 13. But then I was in the Congo at the time. And
that was for secondary school?
Yes.
You finished at 13?
No.
Math curriculum.
Yes. But I had to stay in class because there were no option. But my dad was a professor of university, so sometimes he'd take me to campus so I can hang out with the people of the Polytechnic school. And my friends were like 40 years old. We were talking quantum physics and so on. And one of my heroes is actually the dad of the ambassador from Congo, Raissa Malou. Her dad, Professor Malou, was the director of the nuclear center in Kinshasa. We used to have a nuclear center in Kinshasa.
Right.
He's one of the first world well-known Congolese physicists.
Right.
And we had the war in Congo and the looting, so there were things that were stolen. So in the market in Kinshasa, I found a book of quantum mechanics that were used to wrap fruits, you know, and I saw somebody walking with fruits in his hands with some Schrodinger equation on it. I was like, where did you get this? It was like the fruit. I'm like, no, the paper. And then he points to that lady, and I go to that lady and I say, how much do you want for your trash? And that's how I got my first quantum mechanics book. And the reason I'm telling you this story is to tell you that in Africa, people become scientists by a sequence of accidents. Yes. And one thing that I feel very strongly about is that we need to create straight road so that people who want to do this have like a way to do it that doesn't involve picking people trash. Exactly. So then after I finished high school, so I passed the baccalaureate, the state exam. I was first in Kinshasa, waiting for my visa to go to Brussels. It took like forever. And I arrived super late on campus. So my professor told me, you know, you can't pass your exam because first you're from like the Congo, like what can you possibly know, right? And you are so late, so it's better for you to just sit in class and then, but I was from College Boboto. I just want to say, you know, my school is so cool. It's a Jesuit school, Catholic schools in Africa.
Sorry, I think does the sound good?
Yes, I'm back.
So this is the college in Congo?
Yes, the college in Congo was a Jesuit school, but my school was so amazing that, for example, my professor of physics and math have trained 2 people who are in this conference.
Wow.
Including Professor Yala, who was talking about cybersecurity or cryptography, sorry. He actually, when I was in my school, my professor of math, when we couldn't do a problem, it's one of the rare schools where students go to the board all the time. It was the culture.
That's extremely rare.
Like 80% of the time of the class consisted of sending people to the board.
Wow.
And then when we couldn't do the problem, my professor, who was trained originally in literature like Greek and Latin and then became a prof of mathematics, will go to the window and scream, "Yala, where are you? These kids can do this. If you were there, you will solve this problem in 2 minutes." So growing up, I had heroes that were actually other black kids, which is something that people don't think about.
Incredible.
But I had heroes, and what is funny is I met him in Kigali for the first time at the airport as we were coming for this conference. And I asked him who he was, and he told me what he was doing, and then he said, "My name is Sam Yala." And I was like, "I know you." And he was very surprised, saying, "How could you possibly know me?" I said, "The math professor used to go to the window and scream your name every time we failed to solve a math problem."
Wow.
Yeah.
So you didn't meet him, Yala?
No, I never ever meet
He
him
was ahead of
until
you.
we came to this conference.
He was ahead of you.
Several generations ahead, but he was a
Wonderful.
legend in the school.
Wonderful.
And now he's here, obviously. The professor was very right. He's a very talented person. And he also goes back and teach at Polytechnic in Kinshasa a few months per year.
Incredible.
So when I was at University of Brussels, I took my exam. It went very well. I was one of the top students. I got my first job as an assistant to the business school. They told me, you can teach math.
Mathematics, yeah.
So I was doing exercises with the business school students. Some of my students were older than me. Some was not sure that I should be there. Like, "Are you sure it's you?" I'm like, yes, it's definitely me. And they will look at me, and they were not sure. Then they will ask me some question, and then they will, okay. But so my last year, I did my senior thesis with a physicist. I was in math, and I did my senior thesis with a physicist, Marc Hainaut. You know Marc?
Yes, of course.
He's the director of, what is it? Solvay Institute in Belgium.
Yes.
Hi, Belgium. We love you. So then, with Marc, I was working on a problem of general relativity, actual supersymmetry. We were looking at spin 2 and spin 3.5. So these are like the particles that will propagate gravity and the one that would propagate supersymmetry. But we were looking at free fields, so there were no interaction. And the question was to ask, if you want to introduce interaction between these two free particles, what kind of theory you can have? So this problem was solved under a lot of assumption in the 60s by people like Desert, and very well-known gravitational guys. But they made a conjecture, or they assumed the form of the Kaplan.
But don't get too technical, okay?
Yeah, sorry. It just...
And you have to wind up too,
because
we want to get everyone
So
else.
I'll finish with this. So then in my thesis, I basically remove all this assumption by doing what I do like always. So we turn it into a math problem. And the math problem was just a problem of cohomology, classification of some class. So I actually prove this way the uniqueness of supergravity and equal one without any assumption but Poincare invariance. So then I got to Cambridge, and this is how I met this guy here. He was creating aims, and he told me African scientist, and I was like, he is crazy. But now here we are.
You are one. You are one.
Yeah, and I pass it to you.
Thanks. Yabi.
Hello.
Thanks, that was brilliant.
Hello.
Is it?
I think it's on. Okay.
It's on.
So, I think we had a very, interesting story about how most people in Africa get into these sciences, especially in physics and mathematics. And my story is very similar, so I'm not going to repeat it. It was more like an accident that I got into physics, and then from physics to cosmology, again, another accident. But the kind of the underlying principle for me was just, what is fundamental? Like, what is really, because I needed some kind of model that would just describe, like, in a simpler term, instead of, a lot of variables. So physics was kind of fitting. So when Neil was saying, like, he was also interested in biology, the other thing that I was so much interested was biology. But biology was too many variables that I just couldn't fit it in terms of, like, in one coherent way. So that's how I got into physics. And when I was doing physics, mostly I was interested to be in theoretical physics, but I got to Cape Town, and mostly, like, the kind of things I was working and the things that are also somehow that I found accessible were the programming in just in physics, solving some physics problems using computers. So then that's how I got into data science, and basically, like, in cosmology, I work mostly in the cosmic microwave background analysis. So recently I moved more to the statistical side of it as well. So, in general, I am more interested, like, do the theories that we have, the mathematical models we have about the universe, do they fit to the kind of data that we observe? And we know that there is dark matter and dark energy, which is big problems that we know they exist through the data, but we don't actually really have a fundamental theory. So that means any avenue that we go in terms of exploring and finding hint will benefit both sides, like in terms of which data next to observe, which kind of fund to put in which kind of experiment, as well as for the theoreticians to actually again construct some kind of better model. So that's the interaction between modeling and data is what I'm working currently.
Great. Amanda.
So I love to hear the stories, and I've known both of these guys for very long. I've known Jonathan for years, and I'd never heard any of these stories, so it's fascinating to hear them. And I'll tell you a little bit about mine, but the overarching point that I'm sort of thinking about is unrelated. So we have similarities. That's what's so surprising. So when I was small, I was also very unwell, very often. And I had somewhat remarkable parents, especially in some sense my father, who would give me, whenever I was ill, he would give me problems to solve. And I love to solve problems. And I also struggled to sleep, which is a problem I still have. And he used to say to me, don't worry, as long as you're resting, you're getting most of the rest of rest.
Right.
So I learned a lot from my father, and it's a fairly typical thing when you hear from women scientists, the role of, the very early role that a parent can play, or a teacher or a sibling. And so anyway, so I used to love to solve problems. But I was also the rebellious child, the last child of many. And I didn't go to class at school because there were just other things to do. And I didn't study. And
Did you go to class? No.
And classes were in hierarchies then, so I was in the naughty class, and so it was, there were very low expectations of me, except for mathematics, where I always did exceptionally well, and that was just some kind of genetic thing. So both my parents, neither of them practiced, both were very gifted in mathematics. My grandfather used to sit with me when I was very small and ask me mathematics questions and also spelling questions, spell out words. And so it was that very early investment in me as a thinking. And so at some point I remember being about sort of 13 and sitting down for the first 3-hour exam I had to write. It was on geography. And I had snuck out the house the night before to go to the movies. My parents never noticed. And I had nothing, I couldn't write answers. I didn't know anything. Because geography is not something you can just intuit.
No.
And I couldn't sit still bored for 3 hours. It was excruciating. You weren't allowed to leave early. And I swore to myself this would never happen again. I would study just so that I didn't have to sit through 3 hours of my own mind thinking again. And I very rapidly became the top student in the school, which the teachers couldn't quite believe. So often I would get posted the end of year award because they would have thought, well, it couldn't be Welty. There must be an error in the maths. And then they would check it over December, and then I would get posted the award. So it's sort of interesting to hear the sort of paths. But the thought that is occurring to me here is that we never hear about the paths of the people who don't make it to the panel. Yeah. And we are always stuck with the survivor bias of what luck hit me that I am here and that I've made it this far. And the luck continued. It wasn't just that. And I think a lot for me has boiled down to personality and having mentors who've left me alone and in peace. That has really helped. Neil won't remember this, I'm sure. But he hired me as a postdoc in Cambridge. You might remember that. Really? Yes. And when he sent me the job offer, I was very worried because for all kinds of reasons I needed to be back in South Africa often. And when I was a grad student, I used to go back every 6 months. The other grad students thought I was completely mad. I would miss weeks of coursework and always catch it up, but I needed to go back. And I asked Neil, is it okay? I didn't want to accept this offer that would require me to be there all the time. Is it okay if I just come and go? And he said something to me that I now say often to my students and postdocs that I think is probably the most important takeaway, which is, you put this in an email, so I have it in writing. He just said, we just think you're great, and we just want you to do great things, and we're not going to tell you where to be to do them. We just do great things. Of course. And it was I don't know how rare it is because I haven't interacted with enough of other people's professors to see that. But for me, that was the blessing. My PhD supervisor left me in peace. I talked to him when I wanted to. I worked entirely with a first-year postdoc. He had just left his PhD. I started a PhD in string theory because I was not working in cosmology no matter what happened, because I had left South Africa, who has a top cosmology professor, George Ellis. There is no way I went all the way to the US to do cosmology. I was doing string theory, else I may as well have stayed at home. And I started a problem to try and solve a long, old standing problem in string theory, and I was working with this postdoc, and we accidentally stumbled on a new kind of gravity theory that actually is totally interesting for cosmology. Right. And we kept chatting about it with senior people, and I remember chatting with my supervisor and asking, what do you think? And he was like, as long as you're learning something, not much will come of this. Just keep doing things where you're learning, and that's fine. And so I think the punchline, if I can say, is that people often say, well, how do you help women? What are the interventions we need to help women? What do we need to do to make more women in STEM? And the answer is often just to get out of their way. Yes. Just remove the obstacles, and don't worry about who you're removing them for. If you remove the obstacles, then you will also help black women in STEM, who are possibly our biggest, most marginalized group. You will help many. And so if there's anything to take away from what I'm saying is that we don't necessarily need help, we just need space.
Thank you. Prince. I'm very pleased to take some credit from not contributing to some remarkable work.
So
Prince.
I think somehow some obstacles are very good. When I was growing up, I was in a very small town, like a village, but there was a secondary school that my dad was an accountant of the secondary school. And I used to love football. I used to play football. And at the time, it's only street kids who were playing football. And so I'll go out to play football all the time, and my dad will cane me when I get back, and sometimes drag me to his office and make me sit down to learn. And he used to tell me that there are over 20 million people in Ghana. The national team selects 11 people. So I should compute the probability that I'll be one of them. But I wouldn't stop. So he decided. Somehow I found a way to keep playing football. And when I was in grade 6, I had a math teacher who was not so nice. And those days, you used to get caned and things when you're not able to solve problems and so on. but there was a time when he put a problem on the board for us to solve, and this is something I will never forget. We were about 40, 45 in the class, and no one got up to solve the problem. It was a simple linear equation, and I got up to try. I was very shy and quiet, and then after I tried and failed, he told me I will never amount to anything. If I cannot solve this problem, I cannot go anywhere in life. So that night I couldn't sleep. I started gathering all the math books and studying late in the night. When people were sleeping in the dormitory, I sneaked out into the classroom and I was reading and reading. And at the end of the term, some of my friends who were better than me, and I was bribing them with food so they can teach me, I got a higher mark than them. And since then, they were nowhere near me. And by the time we finished school, I finished the best in the school. So I was able to get into the best high school for science in Ghana. But I still wanted to play football. And then my father kept pestering me, and then I eventually gave up the idea. So when I finished high school, I went into the University of Ghana, and I wanted to do mathematics. He said, "I want you to be a medical doctor." But I somehow hated biology, and I will make a conscious effort to score very low marks in biology, and very high marks, of course, in math. And at the end of the term, I'll show him the scores and tell him that, I am just not good at biology. And he said, okay. So when I went into the university, my mind was just to do mathematics. And the University of Ghana had been graduating like 1 student, 2 students per year, sometimes no students at all, for a single major in mathematics. And it's a typical British system where you have mathematical physics in the math department. And I was thinking about physics as a first point of application of mathematics. So I was very excited about doing mathematics and physics. And when I graduated, I had very, very hard and difficult professors. And we graduated 2 students in that year. And we were thinking about what we are going to do. And I remember discussing with my colleague that we need to think about the current problems that exist, and find out which ones we are interested in. But I was interested in solving what is the number 1 unsolved problem in mathematical physics. So I did a lot of search, and I realized that the idea of unifying quantum mechanics with gravity is a problem that has eluded us for almost a century, and I got really attracted to the problem. And so for those of you who may not know about quantum gravity, so the quantum mechanics is just a theory that governs the small world, and it's kind of a weird theory in which atoms can be at different places at the same time and can spin clockwise and anti-clockwise simultaneously, and so on. And the theory of gravity, which describes the universe at large, from falling objects to galaxies and so on, is a theory that, according to Einstein, that gravity is geometry. So the fact that when particles move past massive objects, they deflect, and they do not deflect because they feel a force, but they deflect because the space-time around this massive object is curved. And for a long time, these 2 ideas have been very successful and tested in their own right, but there's no theory that can consistently unify this. And so this is what got me interested in doing quantum gravity. So when I wanted to do a master's degree, and I was thinking about going to America because most of my predecessors all went to America, and I really wanted to go to America and explore these fields. And then when I was about to finish my master's, my supervisor then, who was, I think he was the first student at ICTP. He was a collaborator of Salam, a student of Salam, and collaborator with M.A. Rashid. And he was a very, very difficult professor, Professor Champon. And he was not satisfied with my thesis. And he said, no, still there's more to do. So I worked on some old problem proposals by Cable and Sciama, some ideas about how gravity can be constructed as a Poincare gauge theory and so on. And then I met Ben, who is in the audience. And he was in Ghana for holidays, and he wanted to meet some mathematicians. So he came to my department, and then we were having a conference in differential equations. He attended, and we met. And we were discussing, and he said he was doing quantum gravity, but in 2+1 dimensions. And we had a little chat, and he decided to come with me. He wanted to see what I have done, my thesis. So I walked with him to the department, and I showed him. And he said, oh, would you mind supervising, being my student, would you mind me supervising your PhD thesis? Initially, I said, no, I am not interested, because I wanted to go to America. But he persisted and invited me to a conference. And then I got interested, and we set up a project. And so, in fact, we started a project after a while before I decided to register my PhD in the University of Ghana. And prior to that, there was no PhD in mathematics in the university. So I was the first person to register a PhD in mathematics, and they didn't even know what to do. So it was my case that forced them to create something. And so during that, of course, Ben was teaching at Ames, and I will spend some time in Edinburgh with him, and we'll go to Ames, and I'll tutor whilst he's teaching and so on. And then eventually I graduated. And I graduated as the first person PhD in mathematics after 65 years of the university, because none of the university had never awarded a PhD degree in mathematics. And so coming back to the fields, especially quantum gravity and the whole physics, I enjoy doing mathematics, and I enjoy doing physics as an application of mathematics. And I like a lot of radical ideas that have come up in recent times. There's still a lot of things happening which are not going in the right direction. And somehow we need to go back to the foundations. Maybe I'll talk about some of that later on.
Thank you. Okay,
Yeah.
thanks very much, Brent.
Yeah, thank you. So, as you have understood, most of them, they come from the theory side. So for me, I come from the experimental side of physics towards the engineering. So I will try to be short. I will just, I'm going to introduce myself in a few minutes. Then maybe I can directly talk about the slides.
Sure.
Then we can continue with the discussion. So I'm originally from Rwanda. I was born in this country, in the south part of Rwanda. And I was educated also in this country from primary school, high school, and the undergraduate university. And the way I ended up doing physics, originally I wanted to do mathematics. So when I was at the high school, I think when I was in grade 5, because after the genocide against Tutsi in 1994 genocide in Rwanda, there was a crucial problem for teachers. So especially for a science point of view, we were not having enough teachers, even though those who were having, they were not actually qualified. So I remember up to senior 6, we nearly had only someone who had he was a Congolese. His level was, they called it bachelier. So it is not a bachelor degree, it is somehow 2 years of university in physics. and the level was not good. So then translating that, the education I was getting in physics was not that good. But on the other hand, when I was in senior 5, as I was saying, I met with a good Congolese teacher of mathematics, and he really made me love mathematics. Then I thought about continuing in mathematics. But when I started at University of Rwanda, at that time it was called the National University of Rwanda, because I'm the guy also who likes to do things, who likes to be practical, who likes to think in terms of how can I translate what I know into something realistic that can address challenges of the society. Then I realized mathematics is going to be much more theory and much more abstract. So I decided to go to the side of physics. And also when I was continuing to study physics, I realized, because here is also, you know, in most of countries in Africa, the physics we learn, it is mostly theoretical physics. So undergraduate is mostly theoretical physics, the labs and so on, there is a challenge of getting them. So, and I really wanted to do something which is much more practical that I can translate into real life. So here I did an undergraduate in what we call fundamental physics, which is actually theoretical physics. And when I finished undergraduate, I wanted to continue for a master and so on. Then at that time in Rwanda, we're not having master's courses in physics. So then the option I had was to apply for a master somewhere. So I spent 3 years applying. So I need to get a scholarship and so on. So I spent nearly 3 years just applying for scholarships. And when I finished in Butare in 2006, then I got the first of the scholarships I got around 2009. And then, but that time, I got actually 2 scholarships at the same time, and it was difficult to choose. The one I got was for EMS. So EMS was, I think, 3 years old or 4 years old, something like that. So I applied at EMS, and when I was applying at EMS, I actually was hesitating because mathematical science, I want to do physics and experimental physics. I wasn't sure if I should go for the EMS scholarship. So at the same time, I got another government scholarship to do something called the petroleum engineering. And actually that was much more attractive because they were offering a job, they were offering, it was just a one year contract, 1 year master's, then you come directly, you go to deal with the methanol gas in Lake Kivu. So it was somehow much more attractive. But when I thought about a bit, I realized if I go in petroleum engineering, with then my ambition of continuing in studies and getting a master, a PhD, and so on, I realized maybe this is not a good option for me. So I decided to go for the EMS scholarship. So as Neil said, when I came to EMS, so here in Rwanda, mostly after, because I think we used to be a French speaking, then sometime in 2000 we switched to English system. But for those of us who studied undergraduate before that time, we were mainly learning in French. So I was a purely French speaking guy. So when I arrived at EMS, then we met with people, guys coming from Cameroon, not coming from Nigeria, Ghana, and so on, who are really very good English speakers. Then those of us were just sitting in a class watching lecturers talking in English. Then we were just watching like a movie which is not translated. So, but we managed. So here the government did something good. When we were starting the university, we had to spend 1 year learning English. That also helped. Of course, the English, it was somewhere in the mind, but it was not used so that we can practice it. So we just need to practice. So, but in the end of the EMS program, those of us who were shy at the beginning, actually we did well. And at the end of the EMS program, I was one of the best of the program. I also even got an award at the graduation. So then I moved, because as I said, my plan was to do something more practical. So then when I finished at EMS, I moved to University of Johannesburg. Then I went there to do experimental physics. At the same time also, I think in the same line with what others said, we always learn better through challenges. So when there are challenges, that's why actually the lessons goes inside, and we get, when we overcome them, things get better. So when I arrived at University of Johannesburg, I was a guy from Rwanda. Then they started to ask me, are you sure you are now coming to do experimental stuff here? Most of the stuff we are using here, you never saw them. Are you going to manage to cope with our setups and so on? But I'm shy, I just said, let's try and see what will happen. So I spent 2 years there, and also at the end of the 2 years, I managed to do well, and I got a summa cum laude at the end of my master's program, and an award from the Osei 2-3 from the South African Association for Science. Then my plan was I need to keep pushing to see how I can go far on the side of what I want to do. Then the supervisors I had in South Africa, they said, Prosper, we think you are a good student. Maybe you can try the options of going outside Africa to see where you can get into good labs and see how you can develop yourself better. So the same rule, I knew the rule, just apply and never give up. So I applied to 15 places. So in those 15 places, only 3 replied me. Then in those 3 who replied to me, one was from University of St. Andrew. A professor said, I'm willing to give you a position, but I don't have money. So look for a scholarship somewhere. Then there's another guy from, I think, Israel. He said, yeah, I'm also willing. I will think about it. Then the third one was from the Netherlands. From the University of Twente, he said, I'm interested in your application, let's talk on Skype. So we talked on Skype 3 times, I did the interview 3 times. Then he said, I'm happy with your profile, so I offer you a position and I'm going to cover everything you will need. So then when I arrived there, the point I want to make is, things were completely new. It was an institution called the Mesa Plus Institute for Nanotechnology. It is one of the best institute for nanotechnology in Europe. So the science they are doing is really very advanced. So I had to catch up because my level was down, so I had to catch up. And in the end, I managed to catch up and finish a PhD on a time, and my boss was happy, and we did some good publications. And in the end, then he told me, Prosper, now you are finishing, and I think you are a good student. What can I do for you? He said, do you want to continue with your career in science? I said, yes. Then he just told me, I have a friend from Max Planck. I can just recommend you to go to Max Planck. He just made the call. I have a student that I think he's a good one, so I can recommend him. So then I ended up going to Max Planck. Of course, I did the interview and so on. Then I got a position to go to Max Planck Institute, which is also one of the best institutions for the science point of view. So.
And you're now staff scientist?
Now I'm a scientist, yes.
Yeah. So I think in view of time, I'm just conscious of time. Maybe something you haven't yet mentioned, but you would on your slides, is about the light source.
Yeah,
so
that's
just
actually,
yeah, I think let's skip the slides because I really want the audience to ask questions.
Yeah.
But why don't you just talk about the light source?
So the light source project, as I said, I'm the guy who is experimentalist, who wants to do practical things. And there is always a question, let me introduce like this, there is always a question. Young scientists from Africa and established scientists from Africa, they go outside, and the question is, they can also come back to contribute to the development of science in Africa. But if you are a theoretician and or a computer scientist and so on, you just need to come back here to this side of Africa. You just need a computer, you need an office, and you need a chair, and maybe a secretary or something. Then the papers, and the coffee also, yeah. And the coffee, then you are happy, you just can go in the forestry and think about your questions and come back in office, derive the questions, deal done.
No problem.
But if you are experimentalist, it doesn't work like that. So you really, if you want to make progress in science, you really need to have labs. Yes. So then that's how I ended up in that project. So there is a proposal coming from scientists from Africa of course, we get support from the different institutions, and the proposal is about building something called a synchrotron radiation facility. So a synchrotron radiation, what is a synchrotron radiation? So a synchrotron radiation, it is a special type of light source which is used for the investigation or the characterization or scientific studies of different type of materials, biological materials, chemicals, and solid state materials. And the good thing with a synchrotron, first is a big infrastructure. That's one thing. Then second, such a setup or such a facility not only brings their physicists, it is a facility which brings together physicists, chemistry, biology, even mathematicians.
And people from industry.
People from industry, and even a medical point of view, because you can treat cancers using the synchrotron radiations. So if we can have such facilities on our continent, so first, you bring people, because there is also a way, so we can think about it. It will be a natural way of bringing people. So people will definitely come because there is a reason they are coming. And those who are coming, they are not only Africans, because a synchrotron facility is used by people from all over the world. People from America, from Europe, they also need such facilities. So they can also come to use such facilities. If they come, they can contribute to the teaching at AIMS, to university, and so on. So which will be a good thing. And the last three, you talk about industry, so industry also, there is a lot of practical application for industrial application. And another thing is, you create jobs for hundreds or even thousands of engineers, scientists, and so on. So there's also creation of a job and also of spin-off companies. Because if you have to make a synchrotron, you have to make magnets, you have to make all the details of that goes with a synchrotron. And that means there should be small companies around such big facility which makes and repairs such a system. So you create jobs, you create a spin-off company. So if we can make such facility in Africa, I think that will be an amazing way of doing science and also attracting people naturally to our continent to do science on our continent.
So Prosper, you are on the International Steering Committee of this project.
So yes, this project, when it started, we were calling it an African light source. But if you want to get money from international institution and UN and so on, you need to make a bigger picture of what you are doing. So I'm on the steering committee of the African Light Source, but now we have a bigger project which is called Light Source for Americas, Asia, part of Asia, and the Caribbean. So we call it the LAM project. That now bring together all those parts of our planet.
So it will be located in Africa, but serving a number of continents.
No. So the plan is Africa have a synchrotron, Latin America or Caribbean countries have the synchrotron, and then so each
it's a
collaborative effort. Okay. Yeah.
Thank you.
Yeah.
Thank you very much. So, sorry for skipping the slides.
Yeah, no problem.
Thank you. Yeah, I think I'd love to open it up to the audience. Over there, yeah. Go ahead. Yes.
I'm Tony Apolago. I'm of the East African Institute for Fundamental Research, an ICTP partner institute. The director has been introduced. First of all, let me thank all the panelists for their resilience, for their passion and the great achievements they have obtained. So thank you very much. Again. So I would like to put into this conversation this argument, this question. So quantum is an adjective, and you can put it almost in front of every word. So there are well-established fields that are inherently quantum, like quantum chemistry, quantum electronics, quantum materials. Then there are fields that are turning quantum, like quantum information. Now, quantum cryptography is already a commercial reality. Yes. Quantum computing is becoming such. Yes. Quantum information processing, which is, by the way, the field, my main research interest field, promises every 10 years to become the next revolution. So they are almost always the same slides, just shifted with the time scale. Then there are fields that will become, or researchers around the world that try to make them quantum. Maybe they are already. They are like quantum biology, like quantum thermodynamics. So small ion, single ion. Now, my question is, and it's to all the panelists, what word to put after the adjective quantum for the social, economical, and scientific development in Africa? Where should we point at, especially? So, quantum science, of course, quantum machine learning. So thank you very much.
So great question. Who wants to take it? Go ahead.
I think one of the reasons why we are setting up Quantum Leap Africa is because Africa missed the Industrial Revolution, it missed the digital revolution, and we see a quantum revolution on the horizon like you have described, but there is no research in Africa, there's no capacity in Africa. So the idea is actually to set up this institution to prepare Africa for this quantum age. So we are focusing on the quantum side, we are focusing on quantum information, and of course we have some machine learning, so quantum machine learning overlaps with data science and so on. So I think that the Quantum Leap Africa is one research center that will create a platform for African scientists and researchers across the world to, so we are interested in both in the long-term experimental what we want to do at QLA. Yeah.
Thank you. Go ahead.
First of all, I would like to thank the panel, actually. And the one is seeing you wouldn't believe that you're a physicist, because the perspective that we have about physics is lots of people are like crazy. And before I come to the university, actually, I was thinking this way, like I'm gonna find those crazy people. Long hair, I'm sorry. Sorry.
He's
so
trying to maintain
the
image.
It's the finest panel I've seen in this forum, actually. So it's really nice to meet you. My name is Mohammed Kamal. I'm a physicist. I'm NEF ambassador for Sudan. Actually, the question is that I wanted to ask is, how is it difficult for a young scientist, theoretician, and physicist to go and make his way through? Because let me say that I have a friend of mine. He's young, and he has crazy theories about physics. Like he's saying that the source of the universe and the source of forces is like gravity. He call it the transformation theory. It's crazy, actually. But I've tried to help him. I'm not specialized in this, actually, but I've tried to help him through this. And he was struggling. He wanted to say that I wanted just to show this idea to the world. And I guess we have contacted kind of a journal in Chicago, and they've just refused to publish the things, actually. So the point is, yeah, it is really hard to make your way through. So I wanted to ask you exactly how we could help those young, scientists. The other thing is that I'm a teacher, I'm a lecturer, but I find it very hard to convince the student that physics is easy. So there's like really, because I'm trying to explain it in a very simple way, but at the same time, the perspective that they had in their background that physics is difficult, and so that they can't make it through. Thank you very much.
Wonderful questions. Do you want to, who wants to take it? Go ahead.
Yeah, someone has to give me a mic. Thanks. Okay. I'm going to start with the second one because it's the easier one. So I think we have this idea of physics as being something that you work extremely hard to learn and understand, and I think it's wrong. And likewise, yesterday someone mentioned the fact that if you don't believe in yourself, then you won't go very far. And I think that's also wrong. Some of our greatest thinkers had enormous amounts of doubt And it's worth reading, especially if you're a physicist. Joe Polchinski, the string theorist who just passed away, it's worth reading. He wrote this beautiful memoirs where he talks about all the doubt that he had in his career. So I think the way that you actually make it easy is by building your intuition. And for me, physics is all about intuition. I don't actually think I'm very good technically. I can do what I need to do, but my personal skill, what I bring to every... And you build your physical intuition with good examples. And the way I have learned to be a good teacher in my home environment is to think about examples that we have physical intuition for. So there is no point to talk in South Africa about what it feels like to be on a ski slope. And it is damaging to always talk about angular momentum in terms of cricket balls and rugby balls and soccer balls, because we do not always do these things. Sometimes it's actually ballet or ice skating or whatever is the other context that might... So it's about physical intuition, which you build by finding examples that have meaning to you. Thanks for that. And then on the other question, which is also something I think about a lot, because you know, there's this beautiful, I don't know who said it, so I can't quote properly, but you can't break down the master's house with his tools. And yet in physics, you cannot send a Word document and expect it to be published. Yes. You have to first get all of the tools and then try to revolutionize. And I think from now being old enough that I'm always on panels and committees, the thing I have learned is that people love consensus. We feel so comfortable to know that everybody around us agrees. Yes. And I've stalemated many committees because they want everyone to agree at the end. And I always say, I want my voice of dissent on record. And it's important that we have dissent, because there are actually research studies on situations where there's consensus. Often it points to something wrong. Yes. Nurses not actually recording things correctly, people die because we try to have consensus studies where nothing goes wrong every day in the hospital. And in physics, I think we're at an extreme risk there. Consensus is a good thing. We want to believe in our theories, but the only way that we can do that is a little bit like bones. They only become strong when you knock at them and when you exercise and you harden yourself against. You have to be robust. And so if we treat our theories like eggshells, then they will crumble the second that we have something again. So I think that it's a huge challenge to the field. And I can't give you an answer, because if it were a solved problem, then your friend would not be struggling. And it's got worse with time. Because there is no doubt that before you had a better chance, at least. Now I can't even read everything on the archive, let alone the number of papers that get emailed to me or passed under my door by a stranger. Yes. So I don't know how to solve this problem, except to say that we need to find some balance between building consensus, which we do want, right? Especially in terms of things that are high risk. The consensus is that vaccines are safe. The consensus, those sorts of things, you don't want to damage public policy. But with science, we actually have to say, well, I will only believe the consensus when I know there are people working on other things. And that's why I wish all the funding agencies were here, because you have to fund the other things and you have to support the people who are coming from somewhere else, thinking about something else. And that, the best I can say is to keep supporting your friend in the way you are.
Yes. Please, go ahead.
I would like to point out that it's not okay for people to just, in mathematics, if you come with something that is very edgy, we can still read the proof and ask you to fill the gap, and then eventually you do get a proof. So I remember when I forgot his name, more recent, the gap theorem for prime numbers. We had this person who was teaching in some university without really a position. He proved something that nobody could prove. Came to Harvard to give a talk, entered the room, and everybody was ready to find the mistake. He left the room like a Superman. And in math, these things happen. But in physics, you need to build a reputation for people to give you the benefit of the doubt. So I believe that there is a reason why we can't publish, crazy paper. You need to show that you can do the little things so that people give their time to see if you can do the big things. You have to do things in steps.
But let me just echo what Amanda was saying. I mean, I've always been a little bit of a radical in physics, and I noticed this as senior as I am now, unfortunately. I have noticed whenever I submit my best papers, these are the ones which are rejected. When you submit a paper with new ideas, people are not willing to take the time to, if it doesn't fit with the conventional theories which are prevalent, they will quickly reject it. And I just learned to deal with that. I never take rejection literally. I just say, well, the referee didn't spend the time. You fight, you fight, you fight, eventually you win. So I still believe that the field, I believe that truth wins. But the battle is hard, always. And it's really tough for a young person to cope with this. And unfortunately, when we train a lot of young physicists at Perimeter where I work, and I always ask them when they come in, what do you want to do with your life? What's the point of this? And I must say the answers currently are a little bit disappointing. People will typically tell me, I want to publish papers, I want to get a professorship, I want to make a career, I want to go to conferences and give talks which are well received. And I always tell them, you're wasting your time. I mean, if you want popularity, go into pop music, not physics. This is not a financially rewarding field. It's not. It's a field where the criteria are extremely clear and very difficult to satisfy. We have to describe nature. We have to succeed in describing nature. Very few people can claim that. And unfortunately, the trend is away from this sense. And even fields like string theory and supersymmetry, which are wonderful mathematical theories, unfortunately have promoted this trend. That if ideas are socially acceptable among the gurus of the field, they are true. And that I profoundly disagree with. So now the positive side is that I really see an opportunity here for Africa. We know there's an ocean of talent. There's an ocean of people who've struggled like Jonathan and Yabebal through impossible circumstances and still triumphed. These people don't give up, right? When their papers are rejected, they know I've overcome much more difficult things in the past. They will get through. So I think we need to build that spirit in Africa among young African scientists. We shall overcome. And we're not going to be following the gurus. We're going to be creating completely new trends.
Yabebal.
So what I want to add is from personal experience. So when I was fourth year in the university, I had this idea about, just GR, having multiple copies of the same thing if you time travel and stuff like that. And then probability. So none of them I understand clearly. But somehow it just seems like, and then I wrote and equations and stuff like that, and I said, okay, this is a new theory. And then I went to, my professors, and of course no one in my department was GR a specialist, and no one could help me. But okay, that theory I thought, okay, I have this great theory, but just no one is, taking it. And then there is a mentorship thing that I'm bringing now. So I was working, here is Bruce, I was his master's student, and I was always just coming up with an idea. And at one point, he told me one thing that I really just valued a lot afterwards was, there are, sorry, there are three layers that at least you should consider. First is be crazy, because ideas actually come up, new ideas, you have to be crazy. But then you have to admit that, not every crazy idea is also useful, right? You have to select. So you have to have also that mentality, just which crazy idea to follow. And then there is a third one is okay, if you believe in it, and if you have done that thing, then you should follow it, and then just basically develop it further, have that mentorship. So that was for me, then I start thinking okay, so you need to really just even self-evaluate yourself. Just again, just he was saying, what is the probability even, from that point of view, that your first idea is, the biggest idea? It could be, right? It's just, but you should really consider that self-evaluation. And I think that mentorship is really something very valuable. And when you are in that kind of phase, you should also just contact people. At least, at that time I didn't know, but now there is a lot of contact you can make, and where you can basically ask honest feedback. And that would just tell you at least, is it something to follow up or not? And if you believe in it, you should just follow up and construct it. So that is one thing that I would like to say to your friend.
Over there. I think in the blue, yeah.
Thank you very much. I'm called Daniel Akili Baseme. I'm a British Rwanda scholar from the Democratic Republic of Congo. And I really think that I like science and technology and physics and math. But my question is about this innovation that we are talking about and how the population of Africa is growing. So it's true we are encouraging young people to be more innovative, to create solutions to the problems that the societies are facing. But at some point, I feel like these innovations also sometimes leads to people losing their jobs at some points. So for example, if you're an engineer, you can create a machine that creates, that will be really helping the community, but maybe 100 of people will lose their jobs just because you created that machine. So, and I'm really happy yesterday the president of Rwanda, His Excellency Paul Kagame, talked about the balance, and she also talked about balance. So I would like to know, how can we create that balance between young people being more innovative and people still having their jobs? Thank you.
Prosper.
Yeah. Yeah, thank you for the nice question. So my research also goes in the field of quantum material and quantum technology, and we make different devices that can be used for different purposes. But the point I want to make is, the suggestion I will give when I see maybe the word of 2100 or after, if someone asks me what should you suggest to your kid what to study, I will tell them to look for something that requires to use the brain. So that requires to think, so to be creative and using the brain. So we should move away for things that robots can do easily. Because in the end, that is unavoidable. Because if you have to go in a factory where a robot has to put a screw there, or you have to sit on a boom where you have to push a button and open it when a car comes, I think there is no future for such kind of a job. But if we teach or push our kids or our students to do things that requires thinking, that requires creative, that requires, because robots actually they are not good in that until at least today. So that means the job is somehow assured for you for the coming days. So to summarize, let's focus on job or on studies that requires using our minds, being creative, being innovative. Then those subjects that only requires to do repetitive work that robots can do, let's slowly move away from those kind of subjects. That would be my suggestion for kids.
We need women questioners. Am I missing one? There's one there. Thank you.
Good afternoon, ladies and gentlemen. Mary is my name, Sichangi. I'm from Kenya. I work with the Center for Mathematics, Science and Technology Education in Africa, so my specialization is actually mathematics education. Thank you for the panel, and as you discussed the discoveries that you've made around the areas of specialization, I was caught by what is that Osei?
Prosper.
Yes, said about the numbers that we graduate in these areas, and the fact that he found himself in a field where there were very few graduates in that area. And I thought of the foundations that are laid down through the education curriculum in most African countries. And I realized that's where the problem starts in. How do we teach physics? I work a lot with teachers in maths and science in Kenya and even Africa, very many African countries. So I have facts about what goes on through the education systems in Africa. And the question will be, then how do we ensure that there is space for innovation in the curriculum, for thinking about different types of innovation? You've all talked about the fact that children and students need space to think, but I don't think our curriculums accommodate that. They are more of teaching for exam, syllabus coverage, and therefore you end up with robots in the name of people who can only reproduce after their teachers. And the question of how do we then trickle down what you're saying to these education systems, because that's where it starts. You'll always find very few teachers in this area, very few indeed, more or less one or two ladies. Like when I was doing mathematics and physics and chemistry in A level, everybody told me you are in the wrong field. And I kept on feeling that until my brothers encouraged me. I grew up among boys, and the boys told me, Mary, what I can do, you can do. So that's what made me who I am today. And therefore, there are very many factors. And when you get to higher levels, you find physics very abstract. What is the message for the education sector, in short? That's what I'm saying. What's the message for the education sector? Otherwise, you will be nobody. Because that message is what I'll use, that there is hope in engaging in a field like quantum. I can't even pronounce for now. You know? I would like to go back home and say, there are ladies who are doing physics, and there's something good out of that. How do we take back to the education systems out of what you have shared with us? Otherwise, we don't want you to be lonely. We want to send more people to your side as an educator. Thank you.
Wonderful point. Can I just comment briefly? Although AIMS, when set up, AIMS when it was set up, focused on postgraduate training, we realized very quickly there's huge need and demand in schools, as you mentioned. So every AIMS center has actually become a center for teacher training as well. And the governments, African governments, Cameroon, Rwanda, South Africa, are looking to us to help refresh the curriculum. Yesterday I had a meeting with the Minister of Higher Education for Senegal, who's a mathematician. He spoke at some of the session, and he pulled me aside. He said, Neil, we've got to reinvent the physics curriculum. It's absolutely true. These modern and exciting fields usually are put on the end of the undergraduate curriculum. And that's absolutely wrong, because young kids, these two guys, let me call on them to speak on it. What's pulling you to physics? It's not classical mechanics and thermodynamics and all the traditional subjects. It's the modern stuff. So you speak.
Just want to say again, thank you for the honor. And it's very surprising speaking in front of all of you. It's great speaking to all of you. But yeah, just being a high school student in Rwanda, it's not like the kinematic theories and like what happens when you throw a ball that gets me interested in physics. Because sometimes that's just like hard work that you have to do to pass your course. It's thinking about like the universe and quantum mechanics and how we get order and beauty from chaos, and like total like unpredictability turns into like the vast and beautiful universe it is. That's what got me into physics. That's what like keeps me inspired, and things like this is what keeps us inspired. And just thank you for the panels again. And so definitely I agree with the fact that we need change. We need to change the way our curriculum works. Like right now in my curriculum personally, it's 1.5 years of the heavy physics and the maths that isn't even that fun, and then 1 month of cosmology and a solid few weeks of like relativity. And I think these should be inspired a bit more. We should focus on like, thanks, and like, really, thank you.
This is high school.
This is high school, yeah. Really? Thank you, thank you. And like, yeah, we should just focus on our teachers being more inspiring than just teaching. Thank you.
I have
Well, what got me into physics is, well, just curiosity. And the thing about having curiosity is that you're curious about what isn't understood yet. And that's what's modern now. Not what has been understood and what mathematical equations exist about and all that. That's not what you're curious about. What you're curious about is what you want to provide to what you could, let's say, add on to. Yeah.
Can I add something? Can I add something before we go? So one small thing I can add to what is discussed is, I do think the problem is not the curricula which are not that well organized. So I do think it mostly goes to the teachers in high school. So before I come to AIMS, I was a teacher I taught in one of the high school here in Rwanda. And what I used to do, I used everything I was teaching, the exercise I was giving to students. Before we do the exercise or a new topic, I was translating in real life what actually that means in real life. What is the application of this subject in real life? So then in the end, the students, all they see the equations, that's good. They see how I'm solving those problems, but they also see actually this has application in real life. Then that was actually motivating them to realize that actually what we are doing is not just solving questions and so on. We are doing something. Maybe today we are not applying it, but if I continue, I'm going to have to get chance to actually do something practical from what I'm learning. Yeah.
Thank you.
So I have a tiny, just a tiny addition because we're on the same thread. I think the answer to your question slightly answers the question before, which is, to me, it's a statement about society, what we choose to spend our money on. And it's always been remarkable to me how little money we spend on education, especially early child education. You know, all the research shows that it only matters up to like age 5 or something. It's already, everything from then onwards is roughly set. And so the answer really, if we are looking for jobs for young people and if we are looking to improve the curriculum, is actually we should be investing far more in teachers. They should be paid far better. It's unbelievable to me how poor teachers are paid. And they should be invested in and trained. So we also do these kinds of programs that Neil does, but you cannot do the mass scale that you need to do. And teachers don't feel that they are valued. And if we don't value our teachers, then we are actually not valuing our children. And so for me, that's really the problem. The curriculum is actually neither here nor there. It's just having a teacher who, has some passion and has the space to do their job, and that actually requires money. So my solution is that we should pay teachers far better, and the rest will come right.
But they need to perform better too. And they need to be trained better.
Okay, can I?
So I'm slightly conscious of time, so let me take 3 more questions. You've got a question.
So my name is Ishima Karimba. I'm in grade 9 at Green Hills Academy here in Rwanda. So my question is kind of different from the other questions that were asked. It's just hardcore physics and theoretical physics. So most of you were talking about studying string theory, and it brought me back to something I had read about the string theory about the multiverse, essentially. Different Earths existing in the same space, but their strings vibrate on different frequencies, so they never really touch. So I just wanted someone talk about this or to add on to what I know. Yeah.
Thank you. I think Amanda will handle them.
You want me to talk about the multiverse?
Sorry? Oh, good idea. Yeah, we'll get 3 questions. Okay, let's take another one, please.
Thank you. My name is Marie Chantal Tunyana. I am MC alumni. I teach in your physics department. Actually, it's really...
In Rwanda? Or?
Yeah, in Rwanda, but I'm also a PhD student at University of Johannesburg, the physics department. There is a huge gap in physics, especially for females, women. Like in physics department, we are only 2. So if you go down to secondary school, it's going to be a huge challenge for youngest because they're going to ask you, women are not doing physics, they don't have a role model. So I am asking the government of Rwanda to put more emphasis on women to do physics, especially lab work. You can see this big school, but if you go to the lab, there is no equipment, there is no experienced people. So it's like a comment. Please just try to equip the lab and then try to create this innovation, creativity for women and everyone doing physics. Thank you.
Thank you very much. And the last one. Bernd, do you want to?
I'm Bernd Schröers, Professor of Mathematics in Edinburgh, and was mentioned briefly as Prince's PhD supervisor. And I wanted to add one thing to that story, which is that I also had some doubts about the wisdom of supervising a project on quantum gravity in Ghana for two reasons. One, I discarded very quickly, which is the assumption that most of the mathematical research that's supported is to do with epidemiology, useful applied things, and I thought, what's the place of quantum gravity? But then I thought, well, everybody has a right to think about quantum gravity, so does Prince, so let's do this. But the second thought is that I do feel, and I think something that Neil expressed when he chaired the session, the plenary session, that the subject of quantum gravity and string theory in some sense I think is in a crisis. We haven't really produced any insights into nature for a long time. We've produced beautiful mathematics. And in principle, this could be a great way to get out of this rut. So this is a reason to hesitate, but also to think maybe this is a fresh start for the field. And I wanted to hear what the panel thought. Quite a few of you are involved in quantum gravity, string theory related topics, whether that's the case and what that would concretely mean. Thank you.
Great, so the first and third questions overlap a lot. Let's take volunteers. Who wants to answer? Go ahead. Please, go ahead.
Yeah, so
the string theorist actually doesn't want to talk about string theory?
No, we will talk about string theory too.
Go ahead.
But I'm passionate about this one, actually more. So I teach in an all-girls school, which is in the middle of the Congo, in the Katanga province. It's not in a big city, it's in a village. My students are 13 years old girls. And so...
so you're saying currently you do this?
Yes.
You go back each year?
Skype.
Oh, wow.
Yes, and they are doing very well. And so when I started working with them, they had all kinds of difficulties, and the students have different levels. And so I ran several tests to kind of identify who were my best students. And I really believe that the best way to teach is to actually empower the student to become the teacher. So once I identify my best student, I started doing something that I learned from my own school when I was in the Congo, and that I also learned while I was teaching at Harvard. So I started forming small groups, and then I copy what this forum does. So I just said, my 5 best students, you are now math ambassadors.
Nice.
And so each ambassador owns a group, and I teach the class through Skype. There is a teacher, we share material and feedback. And they started doing so well because I am living in Boston. I might think I'm super Congolese, but I haven't lived in the Congo for a while. There are things that I can explain to my ambassador, and they deliver it so much better to their friends. So by now, in a matter of few weeks, we have done more in mathematics than what they were supposed to do for the year. Why is that? First of all, the girls get so motivated that somebody actually will go from Boston to talk to them, that they want me to be also proud of them, and they deliver an amazing work.
Amazing.
And so now I have this idea that we can have this kind of operation where you have a group of people who go to a place and just do an intense training that target the student. And as we target the student, we also see when is it that they have a problem, and we identify when this problem was born. So teaching girls who are in grade 7, I have proposition on how to change what they do in grade 4. What I'm the project I'm doing now with the girls, they have a solid foundation to learn all kinds of mathematics that require you to have solid algebra. And I want to try it in different places in the Congo. Like when I'm here, for example, I'm grading their homework. And when I don't have time to write their homework, different groups write homework for the other group to challenge them. Can you do this? You know, and yesterday, one of my girls sent me an email from a professor to say, by the way, I think your equation number X is totally wrong. You are missing a sign. And when I saw that, I was like, thanks God we're doing something right. Because as a teacher, when your students start challenging you, showing you your mistake, you know that I can leave her alone. Yeah. And I tell my friends who are in forming classes in the university in Boston and Harvard and so on, that just wait for a few years. You guys are going to have amazing students coming from a place you don't even know the name of, but they are as well trained as any student in the US.
Wow.
And they are trained to also come back and serve their countries.
Wow.
So I think we should do more of that.
Okay, can I take Ben's question?
Please.
So I agree with you that sometimes in recent times, when we go to big conferences and there are a lot of talks and there are a lot of recycling of a lot of ideas, and one does not really clearly see, especially for quantum gravity, whether we are not really thinking about new fundamental ideas. And I think it is time that we go back to try to think differently from the basis. But I also think that we need to get a lot of young people in Africa involved in these fields. When I started going to AIMS, the AIMS students always ask me why I do quantum gravity. What is the relevance of quantum gravity for Africa? And I always answer by saying that when Newton formulated his equations, we did not know that in future goods for villages in the remote areas to the city. So it is very important that, of course, we Africans have different backgrounds, different cultures, and that may influence the way we think differently about the problems. And I mean, in the past 10 years, most of the big conferences I have been to, I am the only African. So I have made a conscious effort to try to mentor people. I have now about 5 of my students who are now doing PhD in quantum gravity and quantum information. One of them is here. So, and it's something that we need to show examples to the kids in Africa. We need to make a conscious effort to mentor them and direct them into these fields, and then hopefully we will be able to think differently and come up with new ideas in these areas.
Thank you. All right, I think maybe final answer. You have the last word. No, take your time.
Okay, I can't think of anything worse than keeping people from lunch. So I'd answer your questions very similarly, which is that for me, I'm a physicist. I want to solve problems, but they have to be testable. And mathematics is beautiful and philosophy are beautiful, but unless I can rule out my theory, it's a bad theory. I don't want to confirm them because that's cheating. It's easy to confirm things you believe are true. And I think the multiverse, there are many different versions of the multiverse. There's a version that doesn't, the obvious version doesn't even require string theory. We can intuitively, you can create multiverse ideas on your own sitting in your chair now. Just the idea that every decision you make splits off, you know, you chat at lunch with people about free will and determinism, and there you have a theory of the multiverse. Every decision you make. Okay, so for me the question is really about how do we prove these theories? How do we rule them out? And that's the case with quantum gravity as well. So I have given up on large collider type things, which I was saying to Neil earlier. I don't think that's the way. For me, the way is the universe. It's a fantastic observatory. It's a fantastic laboratory. It reaches high enough energies in various contexts, in the very early universe or in sort of local parts. You can study a lot about high energy physics just by understanding pulsars, and you will have done very well if you understand pulsars. So I think that's the answer to both your questions. So in understanding what string theory and the multiverse may say, we have to think about ways to rule out the multiverse. And people claim it's not possible. I don't think it's true. I think we can rule out parts of it. And I have a paper on this, so I'm convinced we can rule out parts of it. And likewise, with new theories of quantum gravity, we have to do them, but we have to figure out ways to test them. And the big problem with string theory, it's not just that it's a consensus, it's that there are too many solutions and yet not even one. There are too many possible solutions, but none of them matches all given observations. And I think that problem is going to be broken soon with new technology. So I think that actually there are new ways of doing things, and that our best shot with quantum gravity is, and with all of these physics problems, is to let other fields bleed into ours and let us hit the bleeding edge of others. So that means astronomy, that means machine learning, that means thinking of string theory actually as a field of data, doing data analysis on solutions of string theory, for example. So I think that we have to be thinking about how to rule out our theories and then make more of them.
All right, I think lunch is beckoning, and so let's just thank the whole panel again and thank everybody in the audience. You've made wonderful contributions.